Okay, so now we're going to get into how do you transition from like a word problem to a math problem? How do you take words and turn them into algebraic expressions in this section? In the next section, we turn them into equations and inequalities. But at this point, it's just expressions, which is the thing that we've dealt with up till now anyways. This comes exactly from the SOLs. That's what we're supposed to do. Okay, so we'll look at that again before we finish. And let's see, we got 14 slides today. So there's a problem-solving process that for math, which is somebody presents you with a problem. It's not going to be a math problem. In the real world, everything is a word problem. Somebody says, here's what I need to solve. Here's the situation that I'm dealing with. And a big part of being successful in the world today is being able to correctly formulate the problem that's in front of you, whether it's a math problem or not. I like to say that if you ask most of your parents about their jobs, what they'll tell you, just like we could tell you, is you think you know what you're going to be doing that day, but then something always changes. You get pulled for remediation or something. You don't know. You think you know what you're going to do, but then you get diverted. And then you've got to figure out, and this is a problem-solving exercise. Okay, how am I going to now accomplish what I thought I needed to accomplish, given the fact that my available time and my resources, that has just changed. And that's something you have to have a knack for. And you have to do that like on the fly, because it happens, it'll happen to you more and more and more. But the basic problem-solving process is you can identify some kind of problem that you need to solve, right? There's something that you're trying to figure out. Could be you're trying to predict people's heights by their 2-year-old height or something like that. You're going to translate it into a math problem, something that you could actually use math to solve. Now, how you do that, you can make a lot of mistakes there. I mean, you're never sure, especially the more complicated the problem you're trying to model. There's a lot of room for error. So the next step is, okay, you made a problem, then solve it. As a pure math problem, just solve it. And then go back and try to relate what you solved to the problem you started with. And sometimes you get a ridiculous answer. It's something you thought, you set it up correctly, but it's telling you something like your height should be a negative number. Okay, well, that can't be right. You have to check your answers. We're really trying to figure out this second step right there, which is how do we take words and translate them into math so that then we can use the math skills that we're doing right now. So the kind of words that we use, these are the basics for just the main 4 operations that you should have seen, right? And for addition, the result of addition is called a sum, S-U-M. Right? The result of a subtraction is called a difference. The result of a multiplication is called a product. And the result of a division is called a quotient. But there's other ways to say every one of those. You shouldn't be confused with those words. I had a kid, and he was an 11th grader, and I'm trying to remember the class. It was Algebra 2 at Callahan. And I used the word sum, I just used it. I mean, in Algebra 2, we assume you know that word. He was very confused by the word, and I said, sum, S-U-M, that means addition. He said, what? He was totally shocked by this. But, you got to hear the word, see the word, don't be surprised by the word. It's going to come up. Okay, so let's turn these into expressions. The sum of 2 and a number x. So what does the word sum mean? It's a plus, right? So how would I write the sum of 2 and a number x? 2 plus x. Right? A number n plus 7. Number n and 6. The difference of a number n and 6. Yeah.
What word makes it reverse? Like, you know how there's like a word that makes which that's what they explained last year.
Like,
No, I'm asking a question. I don't need to go.
well, maybe, I'm not sure I understand what you mean. Matt? Okay, go ahead. Matt has an answer. More than?
Okay. I have the answer to the question.
Okay, what is it?
N minus 6.
N minus 6. It says the number n and 6, right? So n minus 6. But could you say 6 minus n? And the answer is no. The order, you got to do it with the first thing first, n minus 6. It changes the value if you switch the order. So when they say this, they always mean the first thing first. Okay, how about a number y minus 5? Y minus 5. Okay, quiet please. Callie, guys, right? How about the next one? 12 times a number y. 12y. How about 1/3 of a number x? Yeah. So you may have, when you wrote down that list, when they said multiplication and they used the word of, that's what they mean, right? If you say 1/3 of something, that means multiply. And then the quotient of k and 2. Well, honestly, it could be either one. It could be k divided by 2, or it could be k over 2. Well, no, I mean, k divided by 2 means k divided by 2. But usually in algebra, we're probably setting it up with a k over 2, like that. And it matters that it's k over 2 and not 2 over k. That would be different. Okay, so next. So do the same thing with those three. This is your, you try. I think. Just a second. No, actually, we were going to do these together. I forgot. So let's translate. We'll do them together anyways. Okay, how am I going to write the first one? Okay, something like that, right? 6 times a number n and you said minus 4. Is there any other way to write that? You know, the way that I think that you might see it is they could say it like this. The difference of 6 times the number n and 4. That would be another way to write the same thing, right? The difference of. Or here's another way, which kind of bothers me, but they throw this in there sometimes. They could say 6 times a number n less 4. Not less than, but just less 4. And I don't like that. I think it's confusing, but I've seen them do that. So there's obviously more than one way you could write any of these right here. How about the next one?
3 divided by 7. No. Or multiplied. Shut up.
Kaylee. Okay, something like that. You know, probably the first thing you're going to say is it's a product, right? It's a multiply. What is going on in between the 3 and the parentheses? Multiply. So you could say the product of 3 and the sum 7 plus y, or the sum of 7 and y, something like that. But it's overall, it's a product. The quantity, sure. So we'll say it like that. What do you say, Kaylee? Say it again. The product of 7 plus y and 3. How about the next one? Okay. Okay, 22 minus and m squared. Another way they might say that is they might say the square of m. It could be 22 less the square of m. The difference of 22 and m squared, right? So there's many different ways to get at the same thing. Okay, your you try is this. Translate that one. The quotient when the quantity 10 plus a number x is divided by 2. Connor, what are you going to say? Like that. Right, the quotient, so overall it's a quotient, right? So we could draw our fraction bar, and we put 10 plus a number x in the numerator and 2 in the denominator. This is too easy. Okay, a piece of ribbon L feet long is cut from a ribbon 8 feet long. Okay, write an expression for the length of the remaining piece. Right? If you start with 8 feet and you cut a piece which is L feet, then what's left? Write an expression that represents how much is left if you've taken away L feet. Callie? 8 minus L, right? 8 take away L. No equal sign. Yeah. Use the pass and sign out. So if you start with 8 feet and you take away L feet, then the way you write that is 8 minus L. You know, what does 8 minus L equal? It depends on what the value of L is, right? Somebody would have to tell you how many feet that is. But again, that's algebra. Algebra is using, you know, letters and unknown quantities and, you know, doing operations on them even though you really don't know what the value is. Okay, number 9, slide 9. Okay, you try. An 8 feet long ribbon is cut into P pieces of equal length. Write an expression that represents the length of each piece. Right? If you want to divide something into equal parts, then you divide like that. 8 divided by P. So how long is each piece going to be? Well, it depends on what the length of P is. Okay. What if P is small? I mean, if P is 1, then the length is 8. What if P is 2? The length is 4. What if P is 4? So actually, as the P gets bigger, the length gets smaller. The number of pieces you divide it in, each piece gets smaller and smaller. Okay, you try. It's another you try. You work with 5 other people at an ice cream stand. How many people then are working at the ice cream stand? Okay, 6. All the workers put their tips into a jar and share the amount in the jar equally at the end of the day. Right? Write an expression for each person's share of the tips. Okay, let A represent the amount to be shared. So you got a total amount is A, and you're dividing it equally between how many people? 6. What's the expression? Because it's you and 5 people. No, this is 6, not 5, 6. And you're dividing that money up between how many people? Yeah, between 6 people. What's the expression? Adam. A divided by 6. The total amount divided in 6 equal parts, that's how much you get to keep. The total amount, right, is A. If I divide it by 6, then we'll get equal shares for everybody. Is that fair? Does everybody deserve the same amount? Depends. I used to work for tips. I was a waiter for actually a couple of years, but like in 2 different chunks. And, you know, you make your money and then you have to pay the food carriers and the bus boys. But... Okay, let's try another one. Quiet, please. Okay, a rate is a fraction that compares 2 quantities measured in different units. For example, miles per hour, right? Those are 2 different units, miles and hours. So when we make a fraction out of those, that's called a rate, right? If a car travels 100 miles in 2 hours, then what is the rate? $100 miles in 2 hours is how many miles per hour? 50, right? Miles per hour. That's a rate. If they have the same unit, if you're comparing 2 numbers with the same unit, that's not a rate anymore. Yeah. Sure, when he's done there. Okay, so here's a you try. And you don't even have to use any of this math. My guess is that if you were presented with this problem and just tried to, okay, now you figure it out, you'd figure it out. Okay? But we will go back and do it that way. But try to understand the problem. Your basic monthly charge for a cell phone is $30, which means you get 300 minutes free. Okay? You pay a fee for each additional minute. Okay? You don't know what the fee is in this problem yet. Let's say that 1 month you paid a total of $3.75 for 15 extra minutes, right? Then how could you figure how much it would cost if you had 22 extra minutes? What would you need to figure out? If it costs $3.75 for 15 extra minutes, then how much are you paying for each additional minute? The ultimate thing is to answer this last question. But if you want, you could like use these questions to guide you through it. Like first, how much is the fee for 1 additional minute? What's the math going to be to find it? Yeah. Okay, so 375 divided by 15. What is it? Got a calculator right there. Okay, so now write an expression for the total bill. I mean, the total bill depends on, number 1, you've got a monthly charge, right? No matter what. How much is the monthly charge? $30. And then you pay the extra fee for more than 30. More than 300 minutes. So let's have a variable which is the number of minutes above 300. We'll call that M. M equals the number of minutes greater than 300. M equals number of minutes, right, above 300. Then what is the expression we could use to find the bill for any amount of extra minutes? Yeah, Sid. Say again? No. 30 plus 0.25. That's not our variable. What's our variable? M. Like that. 30 plus 0.25 M. Okay, now based on that formula, how much is going to be your bill if you have 22 extra minutes? How will you find that? What will you do with the 22? Substitute. This is like an evaluate, right? This is an evaluate. So evaluate this expression for M equals 22 and tell me what you get. Who else? How about Josh? Do you do it? Are you following along? Okay, you need to follow along. You got a calculator, plug it in. What's 30 plus 0.25 times 22? Michael? Callie? $35.50? 30 plus 0.25 times 22 is 35.50. Is that what you said, Callie? Yeah. Like that? All right. Okay, here we go. So that was the end. That's the homework.